Welcome to the homework solution tutorial. This is covering 3F. Here I will be talking about number 1. Number 1 asks, after t seconds, a ball kicked from the ground reaches a height of h feet given by this equation. What is the height of the ball after 3 seconds? Well, to do that for 3 seconds, we know that t seconds is defined as when t is equal to 3. So let's just plug it in. So h of 3 seconds, wherever we see t, we make it 3. So 144 t minus 16 t squared. So we're going to erase this t here, and we're going to put in that number 3. We're going to erase the t here, and we're going to write in the number 3. Once we do that, then now we can just do the multiplication. 144 times 3. That's going to get us the value of 432 minus, let's do 16, 3 squared. So do 3 squared first. 3 squared is 9 times 16. That gets you minus 144. Okay. Do this again. 432 minus 14. This gets us 288. feet. So at 3 seconds, it's at 288 feet. If you don't believe me, we can graph it and we can also see it. So here I graphed it on decimals, and you can see at 3 seconds, it is about 3 seconds, it is at 228. At 3 seconds, it is 288 feet. That's how we can check our work, okay? Next, when does the ball reach its maximum height? What is the height? Well, the maximum height is just looking at the vertex, okay? So here, if we look at the vertex, the value of the vertex is h comma k. So h is going to tell us, because this is the time, and this is k is going to be your distance for this value. We know that it is at the highest distance at this time. So when the ball reaches its maximum height, that's when we look at that. We want to know the time. So what we have to do is find the vertex. So to find the vertex, you need to know a couple of values. So what we can get here is we can use this formula of negative b over 2a. Okay? This is going to give us the x value. All right? So let's take a look here. So a is negative 16, and b is going to be 144. Why? Because remember, this is in the format of a squared. A is in front of the x squared, or in this case the t squared, plus b t. Okay, that's how it looks like. So let's just plug this in. Negative b. So let's see, negative, so let's look at the b first. So it's going to be negative 144. And we're going to divide this by 2. And we know that the a is negative 16. All right. So negative 144 divided by 2 times negative 16. If we do that, we get the value of 144 divided by 2 times negative 16. We get the value of 9 over 2, or this is the same thing as 4.5. So the x value here is 4.5. So it's 4.5. Understand this is in seconds. It's at a certain height. So to get that height, we just plug it back in. So height of 4.5 is equal to, we write the equation, and wherever we see t, we put in that value of 4.5. 4.5 minus 16 t squared is 4.5 squared. Okay, so it's 144 times 4.5 subtract 16, 4.5 squared. All right, this gets you 324 feet. So at 4.5 seconds, it is at 324 feet. That is its vertex. When does the ball reach its maximum height? At 4.5 feet. And what height is it? 324 feet. We can double check by taking a look. We graphed it, and we can take a look. Boom, right here. At 4.5 seconds, it is at 324 feet. And remember, we got this by using the negative b over 2a to solve for the x value, which is just the h for the vertex. Find the number of seconds the ball is in the air when it reaches a height of 224 feet. Well, that one, we know that when it says the height of 224 feet, this is when we know this is the y, 224 feet. Okay, so that is the output. So we have our original equation right here. And it already told us this is when it is at 224 feet. So we just set this equal to 224 feet. And this is going to be equal to 144 t minus 16t squared. Okay. So you're basically solving for the t. So what we can do is we can, I think, are there any some, okay. So that's what it outputs to. So we need this in standard form. So we have to subtract 222 to both sides. This gives us, let's just write that. Let's write this. This is equal to 0. Let's write this in standard form. Negative 16t squared plus 144t minus 224. Okay? To do this, you need to use it by the quadratic equation. So a equals to negative 16, b equals to 144, and c is equal to negative 224. Okay? You would have to use the quadratic equation there. Let me show you the answer and the steps for it. All right, so there you go. That's how you set up the quadratic equation for this problem. If you simplify what's inside that radical, you get a 80. And it simplifies into this. The two solutions that you get are 2 and 7, which are your times. So we can say that at 2 seconds and at 7 seconds, it is at a height of 224 feet. Next, how many seconds will the ball hit the ground before rebounding? Okay, so when it hits the ground before rebounding, the ground that it is, so here's the object, right? It follows a parabola. So the part that it hits the ground, this is actually the x-intercept. Okay? This is when the y is equal to 0. So if you want to do this, you just have to set this equation equals to 0. So set this equal to 0 because that's what the x-intercept is, because if you look at it visually, that's where it hits the ground. So set this equal to 0. Okay. 144t minus 16t squared. Okay. Now you can actually solve for this as well. Okay. All right. When it's like this, it's very neat because all we have to do is add 16t to both sides, leaving you with 16t squared equals to 144t. Then we divide by 16, leaving you, oh, sorry, nope. Divide by the t, so I'm going to divide by the t, divide by the t. Trying to get it to cancel because you see how this cancels, all right? This cancels, leaving you with just 1t. So it becomes 16t equals to 144. Then you want to divide 16 to both sides because you're trying to get t alone. This will get you a t is equal to 9 right here. So you can say at 9 seconds, okay, this parabola hits the ground again. If you don't see it, take a look. I have it graphed, and you can see it starts off at 0, it goes up, and it comes back down, hits the ground at 9 seconds. All right, I could zoom in out to if you want to see it better, but it doesn't matter because you see still at 9 seconds. Okay, it comes back to the ground. So there you go. Basically what you're doing here is you're solving here using the square root. Okay, so set equal to 0, then solve for t. Right, you have to move one of the variables to the other side, then solve for t. Okay, there you go. That is number 1.